So there, friends, welcome to the second of a set of two workshops we're doing in partnership here with our friends at 221A and the Hypha Workers Co-op, going into how can people working as an archivist, and that can be whether you're an artist, whether you're working in a museum, whether you are doing things within maybe like a cultural memory project, then how can you start using some of the ideas of decentralized storage? So that's what we're going to do today. Last week, we went into some of like the nitty-gritty, like the technical, the whys, the hows. Today, we're going to get a little bit more into the hands-on space. And we're actually going to do that with a couple very interesting demos that are going to be quite hands-on. We're going to put you to work too, that Chad has come together with. As you can see from the overview, we're going to work with the IPFS desktop, and then we're going to go in and get a little bit geeky, but in these fun, accessible ways. We're going to talk about content identifiers and fingerprinting and all kinds of cool things like that. And then we're also going to talk about content addressing, which is one of the unique properties of decentralized storage. And we'll show what driven the consequences of addressing something not by a location, but by its actual unique identity as a piece of content. And then I'm going to take us through a little bit of an exploration of an actual platform. So say you're not super duper technical, but you're like, I want to play with some decentralized storage. I'll show you the Storacha platform, which is a way that people more like myself who are just looking to have a website you can log into and upload and download things can play with. And that's all really going to build on the core concept that Chad has put together. So that's the idea here. I think I want to now pass it over to Chad, who could talk a little bit both about some of our learning goals and also maybe have us a quick chance for us to say, who do we have here with us? Because I think we could probably pretty quickly get a sense of who's here in the room to make sure that we're meeting everyone's needs.
Hey everybody, so my name is Chad. I'm here representing the Hypha Workers Co-op, which is a technology consultancy based in Toronto and has people all across Canada and even down in the US. And I'm here today to help spread the gospel or to teach you some of the deep concepts behind decentralized storage. I've been working in this protocol space for a few years now, and some of the concepts are easier to have your head wrapped around them than others. But today should be a pretty gentle introduction, I think. And in that, what I would like, maybe we've got a small enough group. I think we can just do some real quick intros. So it'd be really great to go around the room. Maybe we should go to online first. I'd love to know your name, what organization you represent. And to add on to that, and I'll just pop to this next slide here, I'd love to hear like one or two learning goals, something that is, if you could only get one question answered today, I want this question answered today. I'd love to hear that as well. And I'll record them here on our whiteboard.
Awesome. And so since we're starting with our online friends, we have two options here. One, you are welcome to come on mic and say hello. And if that doesn't work for you, drop an answer into the chat and I will act as your voice and be that person for you. Perhaps I can put a couple people on the spot. Bria, how do you feel about being put on the spot?
Yes, I'm Bria. I'm faculty at Humber Polytechnic, but I'm also working on an independent project of a AI-generated live character. And one of our interests in this workshop was you're generating data and trying to figure out different license models to use. And how do we steward the data that we collect responsibly? So this is like voice, image, objective, conversational data. And for today, I'm just really curious about capacity and management. So I'm here for all of it. Thank you.
Awesome. Thank you. We're capturing that up here on the whiteboard.
Hi, good afternoon. My name is James Crawford. I work for the Haida Heritage Center in Skidegate on Haida Gwaii. Mostly maintenance here. This might not apply a huge amount here, but there is data I need stored in places other than just here. And as well as that, I'm also an artist. I do a lot of digital work, and preserving that is one of the things that I'm looking to learn more about, because at this point I don't have anything backed up. So anything would be better than nothing.
Awesome.
See, David texted us in. David Latham, founder director of artsgroup.org. Just here to tell you what this is. We're passionate about promoting the arts and showcasing talented artists from around the world. Our nonprofit organization is dedicated to connecting the public with the best of arts events, exhibitions, and performances, no matter where you are.
Hi, my name is Maud Baum, and I'm the Artistic Executive Director of EBA Arts. We're a 52-year-old organization based in Albany, New York, and we've worked from the point where electronics were just us working with the mainframe at RPI or one of the other universities to create both live and computer-generated art. But that, of course, was from the 70s and 80s, before anybody had their own computer or there was an internet or anything like that. So now we're working on taking those 50 years of archives and creating a different sort of archive that will allow people, other artists, younger artists, to see how a community-based creative performing organization was created and how we were allowed to continue for over 50 years, which is unusual. And also, all of our artwork will be available for other artists to take it and use it however they'd like, unless we don't want it to be commercially used, of course. But artists can take the work, whether it be music or dance or theater or sculpture or whatever it is, and use it to create their own works with it if it's something that spurs a creative thought. I'm here today because I need to know what you folks are doing.
So what are the building? What's everybody doing? Yeah, great. Hopefully we can introduce you to some options. Okay, so we're going to move to in the room here.
Hi, Eli here. I'm here with TechSoup, and we're my second hat, which is as the long-term host of the TechSoup Connect / Next Squared Tech for Good meetup for nonprofit staffers. And we have partnered with friends here at Hypha and at 221A to run about 8 of these workshops actually in other cities. We've just had one in Chiang Mai in Thailand. We've got another one planned for the Bay Area next month, because our goal for this project is to work with GLAM organizations, so galleries, libraries, archives, and museums, to help them better understand decentralized storage and determine whether it makes sense for the vision and the goals of the organization. I'm going to pass the baton over to Jesse.
Great. I introduced our organization, or I'll introduce myself now. Yeah, my background is as a curator and a nonprofit cultural worker. They're leading the digital strategy here at 221A since 2018 or so. But I'm equally as interested in pixels as I am in painting and sculpture and ceramics and printmaking and all that stuff. Physical and digital, both worlds. I like to bridge them. Just excited to see where everybody's coming from, the different backgrounds. It's great to see you all here learning about these tools that we've been talking about for many years, but they're getting more and more concrete, more and more real. And I'm just looking forward to following the work that you all do and seeing maybe where some of this learning kind of inspires us in your past.
I guess I'm next. My name is Karen Huang. I am from Moving Images Distribution, and I'm a filmmaker, and we're a nonprofit society, and we represent other filmmakers, and we have a lot of their films, and we've been incorporated as a society since 1979. So we've got 45 years of material that we have gone through different generations already in technology, from VHS and then from film, actually, reels, 16mm reel, to VHS and to DVD, and now to a digital landscape. And so I'm trying to learn, this is my first foray into decentralized storage. And I think it's important to make sure our digital archives are secure and kept for the future. So I'm looking into preservation and expanding my knowledge in this area.
Oh, hi. My name is Shuing. I'm currently a computer science online student of Northeastern University. So when our professor Yvonne talked about this workshop last week, I feel really interested because my previous major was the study of literature and arts. And I have worked for 2 defined projects after 2 years. So yeah, that's the reason why I'm here, because the decentralized, it's really intriguing concept to me.
Oh, hi, my name is Yujum, and I'm also a student of computer science from Northeastern University, and taking his distributed system course. So I'm really excited to learn about the decentralization of the data. And I think this is a really important topic because in the age of Gen AI, we don't want to hand out data to the big company, the scary company, and use all our data. So to protect our privacy is really important. So yeah, we're looking forward to the discussion today and to learn all the tools and techniques with.
Great. Thank you. So that's everybody we have here in the room. One more person I'm going to shout out that's online is my compadre, Jinsao, who is also here from Hypha. He's a full stack developer and has really done into these things.
I'm based in Montreal. I'm an artist, developer, and member of Hypha Worker Co-op. Last week, I gave a technical intro, and today I'll be assisting, I guess, mostly the online folks with any troubleshooting questions or issues. Happy to be here.
So yeah, we're talking about cultural data sovereignty as the why of decentralized storage in the lab sector. So what is decentralized storage in view versus centralized storage? So I think some of the big guys, the big companies, those are like Google, Amazon, Microsoft, Apple, the big storage providers out there that a lot of people are using, individuals, offices, but also a lot of our library archives, galleries, and museum collections, their digital assets are also stored on those servers. But one of the problems, there's a lot of benefits to cloud storage. Obviously, we are against cloud storage because that is part and parcel of what decentralized storage offers, is that remote access. But it also provides more local first capabilities for you to control the access around your data. So that's really what we mean around data sovereignty, is that you have more custodianship around digital assets that you're storing in different systems. So unfortunately, on the mainstream centralized services, the terms of service can change while your data is stored there. And we've seen that many times. And now with the introduction of generative AI and all of these companies also building their own large language models, they need huge oceans of data to train those models. And they're going to be taking what they have on their servers already and everything that they find on their social networks and anything that they can possibly legally in a gray area scrape up and put into their LLMs is what they're doing at the moment. LLM is large language model, so just an abbreviation for that. There are other alternatives out there and they're being developed, and we think the gallery, library, archive, museum sector has quite a role to play in ice-breaking that space, showing us what those paths can look like, and then maybe even developing some use cases and some applications for these decentralized storage networks with our materials. And yeah, the project or the workshop today is in partnership with TechSoup and Hypha Workers Co-operative, but the funding for the project is coming from the Filecoin Foundation for the Decentralized Web. So thanks to them. Speaking of them next week, actually, they were very curious what we were doing too. Shout out to that group. But they come from that foundation, is the foundation that's associated with a company called Protocol Labs, who's developed a lot of the technology that we'll look at today around IPFS and Filecoin, with other storage networks. So that's not the only ones that we'll talk about. But for instance, they're very interested in the digital humanities and the GLAM sector and supporting this space so that this early learning can take place so we can talk about what this stuff is. You can get a feel for what it is. It's not totally perfect. There are some learnings there, and it's not going to be for all applications yet. But that's why we come together as different minds from computer science, from filmmaking, from visual art. So all of our ideas together can come up with better solutions. And what we found with decentralized communities too is there's a real appetite to continually, iteratively develop the products into better fashions and to make them bespoke for certain communities as well, because they are very tailorable. So yeah, we've looked at some different options, different hackathons around how would you provide storage for a group who are preserving very important footage and documentary evidence from the war in Ukraine at the moment. What are the access rights around that footage and those testimonies from different witnesses and that sort of stuff? But yes, it should be immutable. We should have raw copies of that information in our history books forever. And that can be done on the blockchain and decentralized storage. So that was like an early example of what we saw about 2 years ago, working with the University of British Columbia. And then since then, we've also developed a prototype of our own with Hypha, that could potentially assist the GLAM sector and maybe even fit into some of the workflows that are already going on around archival. And then, yeah, when you think about cultural data sovereignty, there's a lot of pieces that come into it. There is both where you are in the world, there's a legal jurisdiction depending on your region that you're living in and where that data is stored. There's the knowledge systems that come into that cultural data, right? So cultural data isn't just one thing, it comes from many different cultures, and there's many different knowledge systems that support how that knowledge should be shared, should be held, should be learned, should be accessed. And so we have to think about those knowledge systems coming from a European perspective, coming from an indigenous perspective, coming from many different global perspectives. So that kind of thinking can also be thought about when thinking about data storage and sovereignty. And then also there's the physical side of it. What are you using? What's the hardware? What's the cloud storage? Is it local? I always call centralized storage like the secret third option that is both in the cloud and it is both very tailorable and local first. So yeah, those are just some of the touch points that you have to think about in terms of this concept. So there's no one definition of what data sovereignty is or cultural data sovereignty is, but it's something a community can define for itself when it thinks through all of those positions and all of those factors around what it's trying to do. So yeah, if you have specific examples of where you're coming from or what you're working with, I encourage you to talk about that throughout the workshop. When we're doing the one-on-one stuff, might be able to hear about the use cases that you're thinking about as well, because that just fuels what we're thinking about for our research and our development on that front. And just to say that we're here to help build over the long run. Our mission in the digital realm is to create a more fair data ecosystem so that the data that we're all working with, it's a more fair playing field, and we have the tools and we have the knowledge and the resources needed to maintain that sovereignty and custodianship over what we're creating and what our communities have created over the past several generations, if not centuries.
So today, what we'd like to do is introduce you all to a protocol that is used for decentralized storage, and including a few of the concepts that are part of it. This is not the only decentralized storage system that's out there. There are others, but a lot of these concepts are quite similar from system to system. So that's my goal today, is to help you guys understand a few of those concepts as you think about future applications for the work that you're trying to do. Today, we're going to talk about IPFS, the Interplanetary File System. And here we have a really simple quote. IPFS is a peer-to-peer protocol for storing and sharing data in a distributed network. It uses content addressing, CIDs, instead of traditional URLs, ensuring files remain accessible as long as at least one node pins them. Ideal for fast censorship-resistant file retrieval and decentralized web hosting. So that is just the definition. We're going to work through this definition this afternoon, but I'd like to start off really with a couple of terminology checks. First one is file system. Okay, that sounds like a very innocent term, but what's a file system? And could maybe you give me an example of other file systems that maybe other people would be familiar with here? And people in the chat, like online, please dump your answers in the chat. If anybody here has any file systems, you're looking like he's looking directly at me. Computer science guy right in front of me. What?
You mean a physical one or?
Anyone that you think that like most people would know?
Oh, I think most people like a closet at home.
A closet, yeah.
Closet, physical closet.
Yes, just like with drawers and with files. Yeah, like we're in real physical there. Absolutely. Okay.
And there's a digital at the iCloud.
iCloud? Okay.
And
yeah, that's certainly like a filing application. What are the protocols? Anybody got one?
I guess on my computer on Macintosh, the system having the Apple file system
AFS
is the main.
Yes, that's correct.
And it's got all kinds of features that I don't understand. But mostly it'd be like when I put a file in a place and then I go back into that folder, it's usually there. This is what I put.
And another one, remember the old Windows MTFS is another one. So these are the protocols that help the computer understand what is actually happening. You don't necessarily interact directly with that protocol. You interact with the applications that are built on top of that protocol. And that's very similar to what IPFS is. So we're digging deep into the protocol land here, and then we'll come up into the application space in a little bit. But I just wanted to double check file system. The second thing is a special word on this, and it's the I, the interplanetary. What the heck does that mean? And what that means is it's a dream, but there's a really great website called areweinterplanetary.org, and where people have been tracking how interplanetary IPFS actually is. And IPFS last year, 2023, I believe it says, 2023, through experiment with Lockheed Martin, was able to actually get the file system into low Earth orbit. So not quite interplanetary yet, but someday we'll have an interplanetary system. Okay. Today, what we're going to be doing is I'm going to switch over here. Let's get ready here. I would like you guys to open up IPFS desktop app, which we asked for you to download. If anybody online hasn't, I think everybody in the room here has it, but if anybody online hasn't downloaded it yet, there is a link in the chat for you to download it. And we're going to take a little bit of a tour here. I'm just going to have a little walk around to see if you guys have it up and running. Yes, very good, very good, very good. Okay, excellent. So the IPFS desktop application is an application that it was built by the IPFS team to help people explore IPFS, what its capabilities are, to allow for people to inspect the system and check it out. So it's not necessarily a consumer application that you would use every day like a Dropbox. Think of it more like the kind of software that you would use to inspect the inside of your car. Right? There's all kinds of stuff happening inside of your car that you don't know about, and this is a way to check it out. Or like an EKG. Okay, so there's a whole bunch of interesting technical bits and bobs that are inside of here that are great to explore, but we're not going to touch all of them. We're not going to answer all of them today. It's a little bit, it can get a little wild, but don't be intimidated. So we're just going to take a quick little tour here. If you take a look at the peers, first we'll start at the first tab. Yeah, the peers tab. Actually, the first tab is stats. Yes. So the status tab. So if you have IPFS started up, that means you have an IPFS node running on your device right now. And you can take a look at that status tab, and the status tab will show you the throughput, like what's happening, what kind of input and what kind of output is happening in your node. Since you probably don't have any files in your node right now, you're probably not seeing a lot of activity here. But if you did have a whole bunch of different files here, you would see a lot of throughput going. Let's move on to the peers tab. You guys, if you're online, please follow along. And the peers tab, I like this one here because this shows you all of the different peers that you're currently connected. When you first start up the app, it'll be few. It's connecting to local peers, and then over time, it'll connect to more and more. If you leave this online for a while, that peers number will generally go up. And then some peers will drop off and some will come back on. You can see, and then you can actually use this to directly connect to a specific peer. So if you did want to have computer-to-computer interactions, you could do so through this screen. Let's take a look at the Explore tab. Sure. If you click on here, so this Explore tab, what the IPFS team has done is they collected together a bunch of large archives that you can explore using the IPFS desktop application. Project Apollo, the XKCD comic, all of the archives for XKCD are available on here. Don't dig into the WP. It's not as easy to navigate, but at least it's stored there and you can take them out and do other things with them. But this is just an example of some of the different things that are stored on here. A couple of years ago, the country Turkey decided that they were going to shut down Wikipedia and block Wikipedia in the country. And what Protocol Labs did is they quickly mirrored Wikipedia on using an IPFS protocol and made it available off of the internet on the alternate, off the World Wide Web, but basically on top of IPFS to allow people to have access to it. And so Wikipedia is even in here, is even on the IPFS network. Let's take a look at settings we don't need to worry too much about, but let's look at files. Today, we're going to be spending most of our time here in files. Okay. And this is for people that are new, it's going to be blank, but we're going to be adding and removing some files in here. But let's get started. So why don't we add some files? So as our first sort of hands-on move, and we're going to be talking a little bit about content IDs and adding some files. So if you can dump into my screen first, give people a chance to see. If you can grab an image, I would say go to Wikipedia. Oh, I'm sorry. I got to share mine. Sorry. Thanks for doing that. That was so good. Yeah. Except for now, I've got so many little. Of course, you guys have to hide the share. Like this. And here we go. Okay. So please you could grab an image just off of your desktop or something that you have. But if you don't necessarily want to share any of your personal information on here, because this is my first warning to you, is IPFS generally is public only data unless you do some special stuff to it. So anything that you put on there is going to be visible. So that's why I say, let's go to Wikipedia or someplace like that and just grab an image. I went to the Mona Lisa page and I grabbed an image of the Mona Lisa. And what I would like you to do is grab that file, put it on your desktop, and then duplicate that file a couple of times. Okay, so on a Mac, you would just hit like Command D to duplicate it. On a Windows, I'm actually not sure what you right click to finally duplicate. And I'd like to get 2 or 3 different copies of the exact same file on your desk. And then maybe give them a name, like I did, like Mona Lisa 1, Mona Lisa 2, Mona Lisa 3. Simple that. All the same file, just duplicated and with slightly different names, just so I could discern from them on my desktop. Once you've got that, then grab them and throw them. You can just drag them into the Files tab in IPFS desktop once you've got your duplicates.
So go in, you go to the Files file.
Whoa. Okay. Oh, okay. Interesting. Oh, yeah. 0, 1, 2. Okay. Interesting. Now, once you've got your 2 or 3 or 4 duplicates, however many you made, thrown into the file system, just tell me if you notice anything special. If anybody online notices anything, feel free to drop a comment in the chat.
So I've got a comment here from Bria, says, house was a sign.
Oh, interesting. Oh, already in the goods. We got some good terms coming out here. Okay, excellent. In the room, what did everybody here notice?
Under the name of the file, the very long sequence, so that is the same to all of their fans.
Exactly. So that hash, as Bria pointed out, is called a content ID. And you notice that it's not linked to the name is different. You might have a 1, you might have a 2, you might have a 3, and you change the name of the file, but the content of the file is absolutely exactly the same.
So check this out. So when you go into there, just as he's mentioning, so you'll see I've duplicated the same file here. So I've got like decentralized storage, test image, 3 and 2. I even got one here that said this is definitely a unique image, no lies. But you'll see that for each one of these, the big long content ID beneath it is exactly the same. You can see they all end with BG. So I've uploaded these different things with different file names, yet they all have the same content ID.
But if you were to crop one ever so slightly,
Let's test that right now. So you have 3 of these things or 4 of these things on the desktop right now. I'd love for you to pop one open, one of those ones that you grab, and just do something to it. Either crop it. I put sunglasses on the Mona Lisa myself, put a little annotate it, write your name on it, put some graffiti on it, whatever, change it a little bit, and then drag it and put it back on into IPFS desktop files tab, and tell me what you.
So I'm going to open up one right here. There's an image that I created. I'm going to drop my signature right on top of it. Boom. There we go.
Excellent.
So now I'm going to take that, and I'm going to save that with the exact same file name as you've had before.
Just back.
Okay, and
The files.
back out. Now what I'm going to do is I'm going to take this thing, which are just
It
monitors,
actually had the same name.
and actually I'm going to go
wrote.
and I'm going to upload it.
Oh, actually, no, block. So we have to. So if you just adjust its name, call it edit it or something like that, just to make it unique. Okay, just wait, get a return. And right up there, and then you'll see that the content has changed. The content ID has changed. It's not. Did it change?
Yep.
Yeah, it did. Okay, excellent, great, excellent. So now we've seen like even just a slight adjustment, even if you just dropped a little tiny 1 single pixel red dot right in the Mona Lisa's eye, it will change. It's really quite simple. Okay, so what is this? Bria has already given away a little bit of the plot, but this is a type of hash. And I'm going to go back, just change my presentation here. and just take over. Okay, excellent. Okay, so content identifier. So what is it exactly? I'm going to use this, I'll explain it using a bit of an analogy, and that's fingerprints. Okay, so just take a look at this screen here. I have a fingerprint down the left. Tell me, whose fingerprint is that? Okay, we don't know. Well, that's interesting. You cannot. So fingerprints have a series of interesting properties. One, they're unique, but also you can't recreate a person from a fingerprint. You cannot recreate content just from knowing what the content identifier is, but you can tell certain things about that content. The truth is fingerprints can be made from more than just people. This was in fact a koala's fingerprint. And we could also have digital fingerprints. So this one right here is a sort of fingerprint, and this is a hash. IPFS generally uses SHA-256 hashing algorithm. So this here is a hash, and there's several common hashing formulas. The one that, like I just said, that we use SHA-256. Anybody can use it for free. It's available, and you can go and hash different types of content and figure out what the hash is for that content. But really, with this formula, with this algorithm, no matter what you put into it, whether it's a phone number or if it's like a 2-hour movie file, it doesn't really matter. You're always going to get a certain number of characters out. And that is effectively the fingerprint of that content. For example, here's a couple of examples here. So these are 64 character ones. The word koala, always, whenever you run it through the hashing algorithm, it will always come up with the content on the right. And the entire text of War and Peace, a 1,200-page book, when you run it through, always, it will show up on the right. And if you change one letter of War and Peace and run it through, it's going to give you a different hash. Okay, so this is a very interesting computer science concept to use. And I love hashing. Content identifiers are just so amazing. We'll dig into it a little bit more. So in this case here, just like fingerprints, no two hashes are likely to match. We have a couple of different koalas here, but hashes are completely different. Even if you had that top koala and you just put like a little tiny dot and ran the hash, the koala would have a different hash. So just trying to get this a bit across. Okay. Now, content identifiers or CIDs are really important when you're talking about decentralized storage. Just to recap, they're a kind of fingerprint. They're derived from the content. Okay. You get them by looking at the content. You don't get them from a third party. You get them through looking at content. They are unique. So how can we use these? I want you to keep that question in your head as we move on. But I'm going to take a little bit of an intermission just for a moment here. And I just want to thank Starling Lab for this little diversion. We use their slides to talk about koala fingerprints. Starling Lab is an organization that Hypha works with, the organization that I'm associated with. And they had there was a really good article in the Rolling Stone magazine from a couple of years ago called The DJ and the War Crimes about images that were taken about war crimes and then being cryptographically protected and used in cases. Using things like content identifiers and hashing algorithms as a way to indicate whether or not an image is real or not, or whether it's been modified. Okay, really important work. So I just want to thank them very much for that. Okay, so moving on. Now we're something completely different. What I would like you to do is navigate to this URL. Eli's going to drop it into the chat to help because this is my personal website and my last name is really hard to spell. So you can just click on there. And I would love if somebody online could explain to me what they see when that URL resolves. You can use the QR code there too. That goes to the same place. Don't worry. You can trust me. It is secure. What do you see?
And for bonus points, can you identify the source of that? That's exactly. That's what I also see.
Very nice explanation there. So does everybody see the cat? Okay, what I would like to do is just make an R and just refresh the page. What do you see?
No cat.
Bye, cat. Okay, interesting. So what's going on here?
Looks to me like there's a web mesh they're running amok.
A tricky one. So how do you think the way that this works is different than IPFS?
So as someone who has managed a couple of websites badly in the past, I've certainly done this very thing before, which is, I have a version of the PDF of the annual report for my organization. And then like, I forgot one of the donor names. So we go and we make a new version, and then I just upload that file with the same name right over top of it. And I do that because they don't want to break any of the links that I already have on the website or make it break. So basically just replace the content with whole new content, but has the same name.
Right. So this is how the World Wide Web works, how file systems on the World Wide Web work. But IPFS is slightly different. So we're going to just move on here a little bit. Let me give you another analogy. So the cutest kittens ever book. Excellent book, highly recommended. How would you tell somebody to go find this book? How would you tell them to find the book?
Google search.
A Google search? Okay, that's good. That's good. Okay. What about physically, in the physical world? Yeah, go to Amazon physically?
I was just at the library today and I said, to buy a book. Yeah, take the left and then you go to the little full-held book section and look under V for your name. So that's what I didn't find.
Yeah, good. Yeah, there's another set of directions here. Go to the Strand bookstore at 828 Broadway in New York City. Take the elevator to the second floor. Find the third bookcase on the right in the children's section and get the book that's 16 inches from the left on the top shelf. That is a way of telling somebody where a piece of content is. We do have another way of doing that when it comes to books.
Yeah, I've seen there's some library nerd in the chat here.
Oh, oh, excellent. Boom. IPN. Exactly. Or you could just tell them PN is this long number. So when we look at what the web, the World Wide Web, this sort of internet that we're used to, you can see that what we're used to is something called location-based addresses. Addresses are based on location. First, you have to go to the server under that is represented by this domain. Then you have to navigate to a subfolder, which then also has a subfolder, which then contains my content. How to find content is absolutely has nothing to do with the content itself. It just has to do with the location of where to get the content. But in the case of IPFS, by using the content ID is basically an ISBN. We don't even need to know where it is. It doesn't matter where it is. I just need this content, and it will pull it from the network. Okay, this is a great advantage of IPFS and of the content identifiers. So just to recap. So CIDs are a kind of fingerprint. They're derived from the content. They can act as addresses, which is very cool. What else can they get us? I'll give you a moment to think about it. Just think it around here. I'm going to try this. I'm setting you up for the next concept here. And the next concept is trust. So in this model, in the WWW model, where does trust come from in this model? How do you know you have the right image? How do you know you have the image that you want, the one with the cat, and you're not being served the image without the cat? Where does trust lie in the web?
Yes, in that case, did the trust lie with you, Chad? Basically, we had to trust that you were feeding us something that we thought we were getting.
Truly. So one was the person that you shared the link with you. But say, for example, so in this case, I own this site. So you're trusting me. But what happens if I share like a link that I found off of like Blue Sky or something like that, some social media, and I give you the link, go read this article. And how do you know that article is legit? What are the signifiers of trust that you tend to look for?
The publisher.
The publisher? And it's called like the domain. Is it NewYorkTimes.com or is it like NUTimes.com? This looks a little bit fishy, right? So the trust really comes from authority. It comes from the top level domain. You're trusting that top level domain with everything that's underneath it. Okay. But in the world with content identifiers, you don't need to trust the top level domain. If you can run the hashing algorithm on that content and that hashing and that hash that CID matches what you expect it to match, then you know that you have the right thing. You know that you're not dealing with tampered information, right? Which has all sorts of different applications you can probably think of. Okay. And so what this gives us, I'm leading to the concept of immutability here. Immutability. Okay. So what does it mean? Immutability, folks. Anybody in the chat? Oh, other users and CEOs. Oh, sorry, I didn't see your comment there. Can you explain what you're trying to get at there? We'll take a moment here and see. I don't know if it was stable, then maybe you can see your additional usages. Sorry, I'm not capturing what you're throwing me here. And maybe she can't come on voice right now. You can come on voice if you want, but if you don't, it's going to be like a long paragraph.
Hi there. Yeah, I'm just in a public location.
Sorry.
I guess this is the perspective that you're giving is more directory based. And when you have a directory, sometimes you can see the analytics, like number of users, who's visited, who's downloaded, etc. And my guess was just rooted in that idea was if it's a stable content ID, you also have a worldwide perspective of all the users of it as well. But I'm not sure if that's visible.
That is an excellent point, actually. So that's the thing is if you use a Wikipedia image if you grabbed a Wikipedia image and you threw it on there and you got that content ID, and then you deleted it out of your IPFS files, but you took that CID and you search for that CID, you will find that file again. And the reason is because there's only one of those on IPFS in all the world. There only needs to be one because you just grab it. You grab chunks of it. And so that is actually, to your point about a stable ID, that is another thing that kind of comes out of CIDs. It's pretty magical. But you move on to here, immutability. So immutability, what does this mean? Anybody know this term? Have you heard this term?
Something you can not modify.
Not modify, right? The opposite of it is mutable, something that is modifiable. And these are immutable objects. And so you cannot modify them. When you do modify them, you end up with a totally different object. Have you heard of this term in other networks before? Has anybody heard this term elsewhere? A common place that people hear this is in the blockchain world. We talk about a lot about immutability, right, in blockchain. So, excellent. Yeah, so what this basically gives us is verifiability. The ability to verify whether or not content is the real piece of content that we actually want it to be, which, as illustrated by the Starling case, is very useful when you are trying to determine whether or not an image has been manipulated. If you're going to go and take it to war crimes tribunal or something like that, or if it's a piece of art that you want to make sure that it has not been modified. If somebody even takes a photo of a piece of art and they can cryptographically seal that photograph and then distribute that photograph, and I know what the hash is from that photograph, I know that nobody has gone in and adjusted this. I don't need to rely on a third party to tell me this is the real one. Immutability. Okay, great. Okay, we're doing good on time. Okay. I was rushing a little bit because we were slow on the uptake, but I think we're good. Okay, so I'd like to move to a third demonstration here. Okay, and we have 3 people in the room, and I'm going to use these 3 people in the room because I think this is a good test. Sorry, people online, we're just going to keep this one local just because of for networking purposes and the challenges with networking. So what I'd like to do is our 3 people here, I will start off with, let's start off with gentleman in front of me. Sorry, I've got you. You're doing. Could you grab a totally unique image, like maybe take a screen cap of what you're seeing right now that is totally unique, drop it into IPFS files, grab the CID. You can copy the CID by clicking the little 3 dots on the right and just copy CID. And then share it in a chat. And then Sharif, was that you? Yeah. What I will do is get you to load that file.
So friends, so I've
You
got
can see what's happening on mine. Thank you.
all good. So what we've got here, so I'm going to go and basically take it and copy and paste this thing. From there, I'm going to go look to the left, files, Then I'm going to go into import. I'm going to go from there to from IPFS because I've already got the FID. So I'm just going to drop it in there. You'll see it highlighted in green around the whole text field. That's basically just a validation saying, yes, this is properly formatted.
It's a real SID.
And so now I'm just going to give it a name, and we're going to call this Chad Screen, and it's probably a PNG.
Yes, please add the PNG.
So here we go. So I'm going to click import. Kaboom. And there it is. So now I have a copy of this. So you give a click here.
Check it.
I open it up, and this is like the screen grab of the slides.
So I'm going to shut down IPFS on my computer. I'm quitting it. I would just close my computer, except I'm like running and I don't want the rest of the people to disappear. So we're just going to pretend like this computer is off next.
Okay.
It effectively is because I've totally shut down IPFS. I'm not running the node anymore.
So it's basically not running a web server anymore. There's no.
So now if Karen can grab that SID from the chat and load it into her IPFS desktop, so you can go import and from IPFS, we got it, paste it into there, export, give it a name, whatever you like, and then just make sure to add .png on the end, because you need to let it know what file type it is. Airstream.png, so import, excellent.
Thank you.
Thank you. That's interesting.
We're very slow.
We're on the same network, aren't we?
Yeah. So the network is probably big gas.
I know. I want to got a wall in between us. This is the reason why I wanted you to do it locally.
Oh,
Bring it not locally, it takes significant amount of time. You actually would have to use an alternative system. Okay. Eli and I tested this earlier today, and it did work within this network. But the point is that you should be able to see it. And it's being started off of his computer, not off of mine. Okay. So if I just pop over, I'm going to steal the screen again and go back to my slides. And then we can let the support people online also see what's going on. Here we go. Share. Excelente. We're back up. So the question is like, where is the content? And in this type of system, if you consume the content, you now start backups. You are the server. We're all servers. Okay, so this is a P2P style architecture, peer-to-peer. And then with the peer-to-peer architectures. Great. What can anyone think of some good advantages to this kind of architecture?
Sure. As someone who definitely has never stolen anything on the internet and used things like BitTorrent, one of the advantages I have found is sometimes you can get very quick downloads because when the file is split up and hosted in so many different places, it means there's a lot of bandwidth and redundancy available. Not of course that I haven't done if you like, but in theory, that is an advantage I've seen.
So in that case, like splitting up, allowing you to download from multiple locations to be able to construct a file locally from multiple locations. Exactly. That's a great advantage. Any others?
Redundancy.
Redundancy?
From an archival perspective.
From an archival perspective?
Which means you want to have multiple copies stored in different locations.
Yeah.
For preservation purposes. And
Yes.
something
Which
like
is effectively what you have here. Yeah. Everybody has like pieces of the SID. And so that you can always reconstruct the thing. And Jesse also indicated another one when he said that, what if the toss changes on service you use? So on the left side, the hierarchical system, which is what we're used to on the World Wide Web, you had a single point of failure effectively, which is same as redundancy, but it's just to put in rehearse. You're dependent on that single server to be able to serve things. So of course, they'll have backups and those types of things as well. Another one is, that's not just a technical thing, it's an ownership thing. Okay. We are dependent on the feudal lord on the left to let us use their system. The old thing, the cloud was just somebody else's computer. And on the right, we can actually, we own what we're doing. It's ours. We control where it's being stored, and our community can control where it's being stored.
I actually experienced this week. I got an email on Monday from Facebook saying, I know that we have live streamed a whole bunch of your events 10 years ago, but in 30 days, we're deleting those files and they're gone. I'm like, oh, I don't have another copy of those files right now. I don't have that backed up anywhere else. I was like, surely Facebook is good at story links. And they are, but they've chosen in this case to change the terms of service. And so suddenly, the thing that I was like, oh, I don't need to worry about this. Facebook has got me covered for my own video files. That is no longer the case. So now I'm actually currently in scramble mode, saying like, where do I put it? And it sounds like, I put it on YouTube. Am I just creating the same problem for myself in another 10 years?
Yeah.
Like, at some point, I may need to actually have some kind of real ownership where I can like make sure that I know where it is and how it's being backed up over time.
Okay, so this is the interplanetary file system protocol, where many different applications are built on top of this protocol to allow you to be able to access decentralized storage. I wanted you guys to have the opportunity to dig in a little bit and to experience some of these concepts one by one. So just doing a quick overview here before we move on to into Eli's section, but some key concepts that we went over today. We took a tour of the IPFS desktop app, which once again is probably not the app that you're going to use when you're interacting with an actual decentralized storage solution. It's not really a decentralized storage solution. It's a way to inspect the network, to inspect the protocol. We talked about content IDs. We talked about hashes, the difference between location addressing and content addressing. We talked about mutability and how mutability can be really useful. And we talked about P2P architecture. So you consume the content, you start to run it. Okay? And like I said at the very beginning, these concepts are not unique to IPFS. It's just that IPFS leverages a bunch of these to bring that in the protocol to be able to bring you the benefits of all these different concepts. There's also a lot more concepts that we did not get into here, and a lot of like tertiary things. This invention has been going for, I think about, must be 10, 15 years ago that one invented it, and a lot has been built up on it. And so today we're supposed to be just a very gentle introduction into some of the basics of it. Okay, and then to move on next, I'm just going to pass it over to Eli to talk about some things to consider.
Sure, excellent. So we talked a little bit about getting closer to the meta with IPFS. We've seen how it operates and how each one of us can be separate nodes. But we also saw some of the things that can fall apart sometimes with that, which is what there isn't a node available at that time. Suddenly, the file is not accessible. There is this concept of ping within IPFS to say, make sure this thing is available. But if we send a laptop, we're not connected to the internet anymore, the file stops becoming available. And so one way that people thought about addressing that is they created this thing called Filecoin, which is a cryptocurrency thing that basically is built on top of IPFS. So the technical underpinnings in the background, still IPFS. So everything we talked about today still holds. But what they tried to do is basically build a financial model of automatically negotiated contracts that will basically say, let's make sure that this file is available all the time on IPFS. And the way you do that, obviously, is you build a bit of a financial incentive around it. So you basically say, I'm going to back this thing with a Filecoin, and basically people could say, oh, we did that payment. I'll therefore basically create a contract with you to say, I will host this trading for, say, Bitcoin reuse, or whatever you may put on the terms of that contract. But it's not something necessarily, of course, individually negotiating person to person. It's much more of an automated thing where you just go, here's what I'm looking for, who can meet these criteria, and then they automatically negotiate out a price around that. Similar to people who have been playing an auction in like setting up a Google ad campaign. You got the same kind of thing. You say, this is what's worth to me. And then they're like, this is what I need for, and it negotiates out the middle point for him there.
So is it like a marketplace? Yeah, in the way the people who are in the storage space that's always available and matches them to the content, but it's an automated thing through a smart.
That's right. But certainly anyone can come and join the network. So instead of saying, oh, those people who participate are, say, Amazon and their AWS servers, you can say, oh, yeah, I got some of the storage space, and I'd be happy to participate in this marketplace basically on storage.
And the incentives are the longer and more stable you store something, that's when you get the rewards. So they are incentivized to store it for consumers.
Yeah. 221A, so what we're looking at building our own server that will host dedicated space for projects like Filecoin. So that it'll always be over and always be plugged in this building. We can participate in that network, and also that gives us a bit of resources then to earn and give back to people who want to store systems on that network.
Yeah, so it's an interesting way, and then you can also do all kinds of cool stuff with it. They can show things that are unique, which I certainly hear from people all the time, just to say, oh, well, anyone can produce any kind of garbage that was produced by an AI thing. How do I show that the thing that I created is unique? And one of the ways, of course, to do that is within this world. So Chad talked a little bit about this, but it's always just, I think, really important for us to come and say, this thing has blessings and curses to it. And so we talked about permanence. Permanence is to blossom. I want my stream file that I put up on Facebook all those years ago to be permanent. I assumed it would be because I'm like, Facebook isn't going anywhere. Apparently I was wrong. But permanence can have downsides. Say you put up the annual report and you misspelled your major donor's name and you want to go and fix it. As we see from that earlier demo, if we go through and change the name of that person, there's now a new CID. The old version doesn't go away. And if you shut your laptop down, that file, because if someone else had also loaded it, may still exist within the network. So someone else can still retrieve it. So it does mean that our mental model of can I pull something back needs to be really thought through when you're dealing with things like IPFS. We've also got this idea of immutability. This is great. Your data tampering, you a thing at a particular time. That's really powerful. But again, sometimes you do a thing and you want to undo that thing. So maybe you interviewed someone and they were like, oh, at the time I felt comfortable sharing this personal story. Life changes. Sometimes you're like, I don't want that thing to be out there anymore. Again, that's really difficult to pull back. It is there forever. And then we've got this idea of transparency, which is so we can show that this chain of custody. We can do really interesting things with images where you can, in some cases, show every single end. You're like, oh, you can walk it back. You can show, here's the version where we cropped it. Here's the version where we changed the color just a little bit and did some color correction. And that can be something really powerful because then you could say, the New York Times, and you want to say, we took this photo at this moment in a war, and yes, we did, and we're not going to lie. Yes, we cropped it. Yes, we cleaned up the image, but we have to show you every step. That transparency is really powerful in building trust. But again, it means that transparency can also be sometimes a danger. If you put up a spreadsheet with people's media addresses and phone numbers, it's there. And they talk about it. It's hard to pull that down. So you want to be quite cautious, especially when it comes to information that you were like, I don't want this to be public. It's probably not a good thing for something like that investment.
I'll just give an example. There's the group in the building featured everything who are building a social network called Perma, which is a challenge to Instagram. So it's a permanent image network, but they're using centralized storage on it. So once you post the photo, it's there forever. You can never delete it. So that's a change, right? And so you have to think about how that affects the network effects, the social effects of being on that perma space. But one way they're getting around it or introducing people this idea is they're reintroducing this idea of the film rule. So there's a digital film rule that you have on your camera, and you're only going to take so many exposures to put onto the network in time. So it makes you think more consciously, intentionally about what images I'm taking, what images I'm sharing and putting up there. Maybe that's a net benefit for us at large because there is just a bunch of slop on there and advertising cheap stuff and stuff people didn't want in the first place. Yeah. So we're trying to think of design ways to make us more considerate and intentional about what we're putting on these networks that are public.
In ways that are technical, but just around design and how to work with people's behaviors and habits.
Exactly, because we're so used to just putting it out there and just changing it when we want to. But
and just not to scare anybody off of this stuff, looking at these risks and benefits, these are very well-known risks and benefits. And there's been a lot of work and research in how to mitigate these risks. For example, IPFS, which is a web native file system, which is a file system that's built on top of IPFS, which does store private data. They figured out how to store private data and using like key management and key rotation when there's people in the room, and in order to be able to keep secret information on IPFS. It's just one example. So there is stuff out there, but it's just, we just want to make sure that you're going into this with your eyes wide open. You're like, okay, this is an obvious risk that you're going to need to consider when you're building when you're engaging with a third-party service or thinking about these things. These are just the sort of natural qualities and characteristics of these systems.
And sometimes, yeah, you're looking for that permanence, that resiliency. If say you've got 45 years worth of video archives,
Yes.
like maybe that's exactly what
That is exactly what we want, right?
Because your danger is actually, ooh, what if that hard drive just like gives up one day? Do I have a backup copy? It could be pretty dangerous work, especially if you must have gone through this so many times already. So as you said, you go from, we went from actual films to VHS to DVDs to digital files. So these are little steps that have the chance for you to like have something go terribly wrong, unfortunately, but also hopefully builds your resilience through the 20 generations. So we talked about how there are some challenges. There are some things that don't work well at IPFS, like things that have changed all the time. If you're running a database, probably not a fabulous fit for IPFS, because every time you make a change, you're like, oh, it's CID, and then that might just not be exactly what you rate the kids. So I'm going to walk us through just something that is a little bit more friendly, and to those with laptops, you can fire it up and we can go along together. Go to Storacha.network. And every time I do that, my computer just wants to auto-completed, of course, the Storacha. Obviously, they've got a chicken with a bit of flame here, so they know what they're talking, they're playing with here. But yeah, basically, it's a place for people to upload and download and manage files within IPFS, but it's basically got that file on layer on top of it. So it automatically has got that the way of this marketplace to help guarantee availability built on top of it. So you go to the fancy website, and I'll probably swap over to the fancy website in a moment, but we'll go through screen grab from the start. And you'll see in the top right, there's a button that says Start Storage. So if this is your first time to the site, you're going to get a little pop-up saying, all right, so your email address in there. And because there is no passwords for this particular thing, basically what it's going to do is say, now I'm going to send you an email with a link to do the verification. So that's what's going to happen next. And so you're going to log into your email, and you're going to, oh yeah, all verified. Or there's, of course, a big, long, ugly URL that you can also copy and paste. Well, so once you're in there, now they're going to try and say, give me your credit card. This may or may not be where you want to jump off today. So what you'll see here is it got the default of everything was 5 gigabytes of storage. We are not going to go over that. Dude, today I did put my credit card in. No problem. But if that's not the today, no worries. We can follow along here together. But basically, it's got with this framework, they're saying like, okay, if you start using this a lot, we would love to start charging. But let's say you get in here. So here's what happens. So the first thing it's going to want you to do is create a bucket. Basically, you're going to want to create what they call a space. So we'll think of it as a folder, a place where you're going to put all of your files. You're going to have several of these. And the reason they actually have we shut spaces is one, you have the organization tool. The other part is you can create a collaborative where multiple people can contribute to a space. So that is one opportunity there. So you can go to there and let me now just walk you through this in more real time. So you'll see here, I'm going to go say click start sharing. It's going to fire it up here. Looks good. And you'll see I've already created this space. But if you want to create a new one, you just go here, click create, and say this is space. Click create, and voila. So you have it. So if you want to switch between your spaces, you'll see at the top here, you'll just click that and go, here's showing me all my spaces. And so what I've done is I've already created a space for this event here. So I'm just going to pop in here. And so you'll see here stuff you're familiar with already. So down below, you'll see these root IDs. And each one of them has that big, long, ugly CID, that unique content identifier. And if you pop into any of those, you can see here is the URL, here's the root ID. I click in here, and then you'll see it brings me into a state where I'm going to go to the file. And see what kind of matching happens. YouTube. There we go. See? This is the file. And just like we've done with the other files, like now I'm hosting this file, and I could pass this thing CID to basically anyone here in the room, or if we were not behind a firewall, anywhere basically across the network, and you'd be able to access that. So that's what's going on here. And then, of course, you can, if you want to upload a new file, you just go click, uploads, and then you say like, all right, let me upload a file. So click the upload, and you'll see here that it says, all right, I'm going to upload a file. I'm going to upload a whole directory, so then basically a folder. And I can upload the third thing, which I don't understand. So and you'll see this got by basically by default, this wrap in directory option. They say keep it on by default, just makes it easier to basically have a viewable directory here. And you'll see at the bottom, it's got these warnings, which we've mentioned before. Public data, permanent data. So before you get too crazy with this, just think through stuff. These are stuff that I want to share out there with the world. And so this is basically a way for you to go through and create some get these files into the system. And so you pop in to one of those files. You actually click in here, and you can see like it's actually got sharded up into different pieces, and we've got a URL here. And so let's take a look at the URL, because I think it actually shows us something that's interesting around the file cleanliness of it all. So you'll see what we've got here is this thing which is Bastila. That's the CID, basically has like the subdomain. And then you'll see it goes here, .ipfs.w3s.link. And so basically this piece here is basically an IPFS gateway. But the thing about this is there are multiple gateways out there in the world. So once your file has gone in and been scattered across the network, Johnny Appleseed style, it means that now you can actually go and pull it down from several different places. So I'm going to copy this CID right here. And I'm going to go to a different place. So you'll see that this one came from IPFS.w3s.link, but there are other ones. So there's also say the one at IPFS.nftstorage.link. And you'll see right here, there's the browser bar, like at this bar, the CID here. So I went and just logged in and put it in that CID and then click return. What happens is, again, we retrieve that same file. And there's actually other ones as well. So you'll see there's another one. This one's at IPFS.dweb.link. So it's another gateway. Again, we did the same thing. Drop that. They actually CID in there. They fit in. Again, here it is. You've got again the social memory LANA file. So you can see that actually it's been already scattered across the network, just like we did here in person, where we each one of our laptops would like serving it. So now we've got these different other sites that are also serving it, because basically we're taking advantage of the Filecoin-ness that puts the financial incentive behind these other storage providers to participate in the network and make sure that a file continues to be available.
How do people sign release if they're looking for a specific for example? In my case, how with these hash URL / like they're very specific.
Yeah,
Right.
they're definitely not guessable. Yeah.
Yes, yeah.
And they're not for personal human consumption. And so the application that you build on top of these types of solutions. So maybe I would build an ARC, kind of like the node library with 221A, but say I'm building a browsing library for your film library. Okay. The browsing library for the film library would have just like maybe a regular type of database interface. I can search for films. It's got all types of metadata. And then when I'm like, yeah, this is the film that I want, I click on the film. It's going to retrieve from Storacha under the hood the user would have no idea what's going on. And it would come back, it would be pulled back and then served to them like that. So once again, we're like digging deep into the protocols and those types of things. So just think of a more user-friendly layer built on top. And so when you're there are some of those solutions that are out there, but oftentimes there is no one ring to rule them all in this business. And you might, when you're work with somebody in Hypha, but you might want to work with Hypha to come up with, or other groups like Hypha, to be able to come up with some sort of interface to allow to bring your solution to solve like your specific problem. So that's a really brown.
Yeah, so but what we see right now is in most cases, people are going to use something like IPFS as their only backup storage solution. Rather, it's often being used as one of the many systems. In fact, in the archive world, they also talk about 3, 2, 1, which is this idea that you need to have at least 3 backups, and I need to be at least 3 versions, and a healthy be different form for the idea. Yeah, anyways, it's archive jargon that I don't fully understand, but the idea basically is 1 backup isn't enough. 2 backups isn't really enough. Like you need to start getting to 3. And so what people do is you would typically have even like a website people are familiar with, and you would probably have the video available as a standard like downloadable link, but you would also probably just put it right there. And here's also my IPFS. You should have it as an alternate storage solution in case maybe your website is like that backup storage is down. You already got another backup, another way to come at that. And also it's a way for you to show that you got like this decentralized machine. But I would recommend it as to be one sort of an ecosystem of backup solutions.
But it does help like with regular web hosting too, because if your media is stored in these kinds of networks, then you're going to avoid a name wrong too. So it's, if you're referring to that, if you want to pull that media into your website, that it'll always be there and you're going to do that. And so it comes a lot of like blockchain based activities because the blockchain can only store so much information itself, but the media it's attached to an NFT that might represent a film rental or like an image associated with it. That media is not on the blockchain; it's on IPFS. But in the smart contract, it identifies that unique object on the network, on the blockchain network, that film or that image. That authentication is there, and it links to something on IPFS, which is a permanent location. And that way, you're sure the link that media is not going to disappear. It's not. If you put your NFT image on Amazon Web Services, you could go away in 2 or 3 years or 5 years, who knows why, that way. So it's a much more, they say permanent option, but we've measured permanence at maybe 100 years. We'll see.
And like the thing is, you had 45 years of film, you don't want to store that on the blockchain.
No,
That is way too much data for that. I thought that many before. But these types of solutions, like these are wide distributed networks that we can attach all sorts of storage to these networks. Just think like the reason why you use torrenting to distribute your Linux ISOs, like all good citizens, is because those are giant, huge gigabytes, terabytes worth of data. And Eli talked about having quickly downloaded these is coming from multiple sources, which is useful, but also just like the breadth of the network is so huge. Yeah, you definitely want to be using blockchain as a storage solution.
Right.
Filecoin is meant to be a storage solution.
Yep.
That is similar to, that has on blockchain qualities.
and then when we're talking about like the browser, right? The storage system is you've got the interaction
Yeah.
to the browser. I think what's happening now is with some film distribution, there is that browser already built. And what happens is you rent the movie or screening, and embedded in that bit of information or smart contract there, the person can download, screen the film, and then the file is deleted. But it's actually technically not off their computer, but somehow the URL or that hash location identifier is like, I think after a certain date, not accessible or so that's through the browser interface.
Right. Yeah. I actually remember a little bit of something with the Hack Pure about the node library, where there's been this idea about like how could we literally about loanable artistic creations.
Yeah, that's really huge part.
Yeah, unlimited.
Yeah,
You can do
yes.
that through smart contracts.
Yes.
So that was a protocol upon we do too with UBC is looking at if you had a collection of digital assets that were tokenized, you can do a time limited loan like a library book.
Yeah.
And then after that time, the asset just goes back into the collection vault. And so, yeah.
And
there's
the
options.
IP is protected.
Yeah.
That's
So there are those types of like permissions, access controls, all of those other types of technologies have been built on top of IPFS.
okay.
And so once again, IPFS is like not the very bottom, like very bottom is like networking, but it's like quite low here. And then you have like storage solutions and you have all these different things that are built up the stack until you get to the video rental service application, which sits on top of all of these different things.
And it's huge because the consumer, the audience member isn't confused by, they're not dealing with Filecoin, they're not dealing with blockchain, they're not dealing with all that kind of material.
When you get into the
Yeah.
car, turn the key,
Yes.
push the gas, the car goes.
Yeah.
You don't, but what today we're exploring what's actually going on.
But I do think, yeah, that makes a really good point, which is a lot of this is still in like the frontier technology.
Yes.
Still considered frontier tech.
Yeah. Whereas I do think it's not going to go mainstream at this time until those other layers get put on top of it, and people like Herbert 2G1 stuff.
Yeah, the future permanent that they're building, that is a consumer level application. So it has decentralized storage. Everything that you post on there becomes an NFT. It's on the blockchain, it's registered and all of that. But it feels just like early Instagram. You just take a photo with your phone. That's it. It's an easy interface, but it's so well made that anybody could use it, but it uses all this technology. And on top of that, you're only allowed to upload an image to that network through your phone's camera. You could never edit the photo and put it on. You could never take a file from the internet for somewhere else and put it on. It's only through a camera lens that it authenticates and puts it up on the network right away. So you can do things like that. So that every image in the network is verified as direct to reality. There's no AI generation there whatsoever.
One of the things that like Starman Lab, they worked with Adobe and they developed like, at first, like the original prototype was like a little box that you put into the hot shoe of your flash of your camera. And then every time it took an image, it basically cryptographically signed that image so that you knew the image came from that camera on that day and it has not been modified. And then you can go and post it. And now Canon and a lot of other like DSLR, like high level, like basically for journalists, providers are now starting to encode that type of stuff. We have a lot of cool encryption going on in the browser now, like the web crypto API in the browser. Once again, my hands are like covered in oil and I'm digging deep into that team. But the web crypto API in the browser allows us to do so many cool things that we weren't able to do before. And it's recent. All of this stuff is developing and coming out. And so there's going to be all sorts of interesting, cool applications in the future. Traditionally, you might have built a film browser application and in your storage is Amazon S3. If you've ever used S3 storage and you just point to the S3, all the actual image files are stored on S3 and they're retrieved by a player and the player is embedded in a browser window and that type of thing. S3 is really easy to use for developers. There's underlying storage protocols that are happening there.
Right.
So that's like Storacha. Storacha makes IPFS super accessible for developers. But end users are never going to see storage.
Yes.
They're never going to see that. So just to give you like the right levels of abstraction here.
Yes. Thank you.
It's like a WordPress, you don't need to know HTML.
Yeah.
Next websites now, right?
Yes.
There are really tools out there.
Okay. Sorry for the difference.
No, we're coming towards the end. For our online friends, I'd love for you to drop any questions you may still have there. Otherwise, we may want to come back to our list of the whiteboard and say, which one of these have we touched on? Where these still may need to be coming into a future conversation, but are beyond what we were able to tackle here today. Chad, do you want to
Yeah, sure.
work us through this?
Yeah, so we had a couple of things on the whiteboard that were supplied by the crowd here. We talked about some questions that came up a few of them came out, like large archives and capacity. And just like we talked about, the amount of capacity that is potentially addressable is massive on this. If you have 45 years of film, you should have no problem actually getting that capacity and putting those archives on. And it's going to be significantly cheaper than running it off of like Amazon Cloud or Google Cloud or those types of things. If you look at the storage rates on things like LilyPath, that's more AI based, but Storacha, you'll see they're significantly cheaper than those commercial offerings. capacity, once again, the problem of preservation. So as Jesse talked about, like the link rot and the idea of preserving things for these networks are built for long term. If you use something like Filecoin, the incentives are there for them to store it. The longer they store it, the more money they make. And so they're looking to store as long as possible. So we have these types of mechanics that are coming out in these types of things. One thing that question came up on like data license models. That's a really interesting one. So we didn't wrote anything to do with that on here. But yeah, well, I think it was a few different examples out there. You know exactly. Do you have any insight into protecting data or like licensing on top of distributed? I'm thinking on obviously UCANs and like capability base, but that's more access control. What do you think about? Have you heard of anybody building anything around protected licensing or enforcing licensing on distributed storage?
So can you hear me?
Yes. Yeah. Absolutely.
Yes, great. So someone previously asked about private data, and then I shared the link from IPFS docs that lists some encryption-based project that use IPFS. And one of these projects is the LIT protocol, LIT.
Oh, yeah.
And again, we're talking about like primitives that are inviting developers to build on top. But so we mentioned NFTs. And so you could have encrypted data that gets decrypted through an NFT. And so if we mix those smart contracts, encryption, and IPFS, you could have this kind of like time-based licensing, leasing, and basically access. So you're packaging it all to have this really specific use case. So that would be an example that comes to mind.
Right. Yeah, I know Perma's working on, and it's a bit under the hood, but part of what they're working on, because they're not just social network developers, but they're the protocol developers, is how can you decide to keep one of your images on a network private? So before you publish it or before you share it with someone, you have an option now that they're working on to keep it private between you and a group of people or individually for yourself too. So that's a big shift as well. And they're working through that encryption challenge as well. So yeah, that's all coming. But ultimately, what we haven't said explicitly is like a lot of this data sovereignty and kind of custodianship is going to be made possible through blockchain tools. So it's really like that tool set is becoming like the economic and the rights management system within the AI economy. And so we're really looking for examples of how we can start to bring these technologies forward, because they're not just for speculation and making monkey pictures go to $10 million or something like that. There's actually like quite a real use case for them now. And finally, it's showing up because we have to do these big challenges in front of the AI economy right now. Yeah, so we're looking at those teams who are trying to bring these spaces together. So don't be afraid of NFTs. They don't have to cost $10 million. They can cost 0.3 cents too, and they can be shared with thousands of people.
Otherwise, thank you again, everyone, and to our online friends for participating as well.